Hello everyone, welcome to Civilianz. So today we are going to start a new subject, transportation engineering. Let's start. So you just pause the video, find the solution for the question, then listen to my discussion. Okay, shall we start? Who are considered as the pioneers in road construction? Who are considered as the pioneers in road construction? We know the answer. Correct answer is Romans. Romans are considered as the pioneers in road construction. And the first road created by Romans are called as Appian Way or Queen of Roads. So you should learn this. The pioneers in road constructions are the Romans, and the first road created by Romans are called as Appian Way or Queen of Roads. Okay, second question. Tresaget provide a cross slope of dash to the wearing surface. So after Roman roads, then came Tresaget method of road construction. So he provided a cross slope at the wearing surface. At the top surface, he provided a slope. For what? To drain off the rainwater. Okay, so what is the slope provided by Tresaget? That is the question. So the correct answer is 1 in 45. The cross slope provided by Tresaget is 1 in 45. That means 1 vertical to 45 horizontal. This is the cross slope provided by Tresaget. One more important thing, the cross slope provided by macadam. Cross slope provided by macadam is 1 in 36. So cross slope provided by Tresaget is 1 in 45 and cross slope provided by macadam is 1 in 36. John macadam is 1 in 36. And one more important thing, Tresaget provided the cross slope only at the wearing surface, but macadam provided cross slope in every layers. Okay. So the correct answer is option B, 1 in 45. Next question. Okay. The point of importance through which a highway alignment should or should not pass. The point of importance through which alignment should pass or should not pass. What is the answer? Yes. The correct answer is option B, obligatory points. Obligatory points are some points where alignment should pass or should not pass. Okay, so you should learn it. So what is an alignment? Alignment is the position of layout of center line of a highway. The center line of a highway is called as the alignment, and the position depends on some points. We cannot create road everywhere, right? If there is a costly structure near, we cannot destroy that structure and construct a road there, right? So this type of structures or this type of points where alignment cannot pass or can pass, alignment should pass, is called as obligatory points. So the points where alignment should pass or should not pass is called as obligatory points. So the correct answer is option B, obligatory points. Next question. Which among the following survey recommends only one particular route? Which one of the following survey recommends only one particular route in the presence of other alternative routes? So we know that there are 4 surveys. The first survey is map study, where we take the map which is available from Survey Department of India. Then we select many roads, right? We select many roads based on our map available. Then the second step is reconnaissance survey. We just go to the field and use our minor instruments to find the gradient, the distance, everything. Then we will cut off some of the roads. Then we cut off some of the roads which cannot be constructed, where road cannot be constructed. After that, the third stage is preliminary survey, in which we take the advanced survey instruments, go to the field, then conduct survey on all the roads and select only one route. Select most feasible route. So the survey after which only one route is available is called as the preliminary survey. And the fourth stage is final location survey, where we establish these points on the ground. So the correct answer is option B, preliminary survey. So after preliminary survey, there will be one and it will be the best route. Okay, next question. Okay. The map shows proposed and existing roads and important places to be connected. Okay, which map shows the proposed, existing roads and important places to be connected? The correct answer is option B, key map. Key map is a map which shows the proposed, existing and all the points to be connected. One more question is there. What is index map? Index map shows the topography. Okay, index map shows the topography, whereas key map shows the existing, proposed and important places to be connected. So the correct answer is option B, key map. Next question. What is the recommended value of longitudinal coefficient of friction? We know the answer. The longitudinal coefficient of friction varies from 0.35 to 0.4. The coefficient of friction varies from 0.35 to 0.4. And there is one more question that can be asked. This is the longitudinal friction. So the value of lateral friction is 0.15. The value of longitudinal friction is 0.35 to 0.4 and the value for lateral friction is 0.15. Next question. So the correct answer is option A, 0.35 to 0.4. Okay. As per IRC, the formation width of a major district road is. This is an important question. So, what is the formation width? Formation width is the pavement, carriageway plus shoulders on both sides. Formation width is carriageway plus shoulders on both sides. So the question is, what is the formation width for a major district road? What is the formation width for a major district road? Formation width is carriageway, the pavement plus shoulders on both the sides. Okay, so the correct answer is option C, 9 meter. The correct answer is option C, 9 meter, and we can just look at the values. This is for plain and rolling terrain. These values are only for plain and rolling terrain. So first case is NH or SH. National highway or state highway, the formation width is 12 meter. The formation width is 12 meter. Second, for major district roads. For major district roads, the formation width is 9 meter. Then for other district roads. If it is single lane, if the road is single lane, then 7.5 meter, and if it is 2 lane, then it is 9 meter. Okay, for village roads, the answer is 7.5 meter. So you should by heart all these values. For national highway and state highway, the value is 12 meter. For major district road, it is 9 meter. For other district road, single lane it will be 7.5 meter, and for 2 lane roads it will be 9 meter, and for village roads it's 7.5 meter. Okay, it is for plain and rolling terrain. It's only for plain and rolling terrain. And when it comes for mountainous or steep terrain, when it comes for mountainous or steep terrain, for NH and SH, for national highway and state highway, if the road is single lane, the formation width is 6.25 meter, and if it is two lane, the formation width is 8.8 meter. And for major district roads, MDR and other district roads, MDR and ODR, the formation width is 4.75 meter, and for village road it is 4 meter. It's only for mountainous and steep terrain. So you should learn all these things, and if it's confusing for you, at least learn the values for plain terrain. Okay, at least learn this value for plain and rolling terrain. Okay, next question. The recommended camber for waterborne macadam is. So the question is, what is the recommended value for camber for waterborne macadam? The correct answer is option B, 1 in 33 to 1 in 40. The values are given in the code. It is easy to learn. You should learn it. So let's just look. The camber is the crosslope provided, right? The crosslope provided on the road to drain off the rainwater is called as the camber. So the value of camber depends on type of pavement. And the second one it depends on is the rainfall. Okay, it depends on two factors. The camber, the cross slope depends on two factors: the type of pavement and the amount of rainfall available in that area. And we can learn these values very easily. We can, based on amount of rainfall, we can classify it into light rainfall and heavy rainfall. And the first road condition is high type bituminous surfacing or cement concrete roads, and the values are, for light rainfall it is 1.7 and for heavy rainfall it is 2. Okay, for heavy rainfall it is 2. And in case of thin bituminous surfacing, we should write this value here. It will be 2 and this will be more than that, right? 2.5. If more rainfall come, we want to increase the slope. So this is 2.5. Third case, waterborne macadam or gravel roads. For waterborne macadam and gravel roads, we can write this value here, 2.5, and then at 0.5 we get 3. Okay, and the last case is earthen roads. For earthen roads, similar thing, we can write this 3 here and the value here is 4. So we can easily by heart these values. So you should by heart these values, and it's given in percentage. For some people it will be difficult to convert this percentage to the ratio value, right? It's very simple. So we can just take 2%. Just learn this equation. 1 by 100 divided by 8. Just learn like this. So in this case, it's 2%, right? So 1 by 100 divided by 2 is equal to 1 in 50. Okay, we can take another value. We can take it 2.5. So what will it become? 1 by 100 divided by 2.5. 100 divided by 2.5 is 40. So the value is 1 in 40. It's that simple. We can take 3. Okay, 1 by 100 divided by 3. 100 divided by 3 is 33.3. So the answer is 1 in 33.3. Okay, it's that simple. So you should just learn these values. Okay, next question. The height of driver and object above the ground level for the calculation of stopping side distance are dash meter respectively. Our car is going and there is an object here. Therefore, calculating SSD, for calculating stopping side distance, the eye level of driver is 1.2 meter. 1.2 meter and the object is 0.15 meter. For calculating stopping side distance, the height of observer is 1.2 meter and the height of object is 0.15 meter. So the correct answer is option A. For calculation of OSD or ISD, the observer and the object. Observer and the object are at a height of 1.2 meter. So for stopping side distance, height of eye level of observer is 1.2 meter, height of object is 1.15 meter. And for overtaking side distance, both height of observer and the height of object is taken as 1.2 meter. Here it is 1.2 meter and 0.15 meter, and here it is both 1.2 meter. Okay, so the correct answer is option A, 1.2 meter and 0.15 meter. Okay, next question. Okay, what is the safe SSD required for a vehicle traveling with a speed of 100 km per hour under ideal condition? So we know the equation, right? We know the equation Vt plus V square by 2gf. Vt plus V square by 2gf, where V is the design speed in meter per second. V is the design speed in meter per second. Otherwise, you know another equation, right? 0.278 Vt plus V square by 254f. V square by 254f, where V is in kilometer per hour. You know, two equations. We can use either of this equation to solve this. Okay. In this question, it's given 100 km per hour, but other values, the time is not given, friction value is, coefficient of friction is not given. But we know that for 100 km per hour, the friction value is 0.35 and the time is 2.5 seconds. Okay, we know these values. We can either substitute these values and find the answer. Otherwise, we can just refer the code. We can refer the codal values. Let's check. So the correct answer is 180 meter. We can come to it. Okay. For design speed 20, the stopping side distance is 20. For design speed 20, stopping side distance is 20. For 25, stopping side distance is 25. For 25, design speed 25, stopping side distance is also 25. And for 30, the value is 30. Okay, for design speed 30, the value is 30. Okay, so it is easy to learn these three values, right? Then we go to 40. When the design speed is 40, we have an easy formula. We can just add 5 to it. We will get 45. Okay. Then when design speed is 50, we can add a 10 to it. We will get it at 60. Okay. For design speed 60, we can add a 20 to it. So it will become 80. For 60, the value will become 80. For 65, we should learn it. For 65, it will be 90. We can just leave that for aside. For 80, we can add double of 20 is 40. So we can add 40, we will get 120. And then for 100, we add here 40, right? We can add 80. So we'll get 180. So these values are easy to by heart. You can just look at this and easy to learn. For the first three values, for up to 30, the design speed and the stopping side distance will be equal. And after that, for 40, we should add 5. For 50, we should add 10. For 60, we should add 20. For 80, we should add 40. And for 100, we should add 80. 5, double of 5 is 10. Double of 10 is 20. Double of 20 is 40. And double of 40 is 80. So it is easy to learn these values. Just remember this value. For 65, it is 90. Okay. Next question. Okay. Calculate the lag distance. For the design speed of 47 km per hour. The design speed is 47 km per hour for two-way traffic on a single lane road. For two-way traffic in a single lane road. For a two-way traffic in a single lane road. Okay. Coefficient of friction is 0.38 and reaction time is 2.5 seconds. So reaction time is 2.5 seconds and the coefficient of friction is 0.38. Okay, we can do the question. Okay, we know the equation, right? SSD is equal to Vt plus V square by 2gf. Vt plus V square by 2gf. V in meter per second. So in this equation, this represents the lag distance. And this represents the braking distance. Okay, so when we are going on a car and we suddenly see an object in front. Okay, so we will just see the object and then apply brake. The time between we see the object and application of brake is called as the reaction time. And in this time, the vehicle will move in the same speed. The vehicle will be slowed down only after the brake is applied. Okay, clear? So the distance moved in the reaction time. Is called as lag distance. Okay. So in this question, the question is asked only the lag distance. So we can just write lag distance is equal to V into T, where V is in meter per second. We can convert. Here the question is given as 47 km per hour. So we can write it as 47 into 5 by 18. To convert kilometer per hour into meter per second, we can just multiply 5 by 18. Okay, then T is given as 2.5 2.5 seconds. Reaction time is given as 2.5 seconds. So we can just substitute lag distance is equal to, the velocity is 47 into 5 by 18 into t, time is 2.5 seconds. Okay, we can just multiply it. So we will get the answer 32.64. 32.64 meter. But there is a problem. We know that it's a two-way traffic, right? It's a two-way traffic on a single lane road. It's a two-way traffic on a single lane road. So vehicle is coming on from both the direction. Vehicle is coming from both the direction. So minimum side distance. So the minimum side distance should be SSD of this vehicle plus SSD of that vehicle. Otherwise, what happened? If two vehicles come and we are not providing enough SSD, then what happened? The first vehicle will apply brake and it requires minimum SSD1 to stop. It minimum requires SSD1 and the second vehicle requires SSD2. If both these values are not given, then the vehicles will collide. So the minimum required distance is SSD1 plus SSD2. But it's the same road, right? Same road, same design speed. So we can write SSD plus SSD. Both SSD1 and SSD2 will be equal and it's equal to 2 into SSD. Okay, for single lane road with two-way traffic, side distance, minimum side distance available should be 2 into SSD. Otherwise, vehicle will collide. If you are providing one SSD, one vehicle can stop, but the second vehicle will collapse. Okay. So here we can just multiply, the lag distance will be 2 into this value, 32.64. So it will be 65.28. The value will be 65.28. Okay, so you get the solution. So the correct answer is option D, 65.28. Okay, shall we move to the next question? Okay, so the next question. Calculate the safe stopping side distance. Calculate the safe stopping side distance, SSD, for a design speed of 60 km per hour. Design speed is 60 km per hour for a two-way traffic on a single lane road. So in this question also, it is two-way traffic on a single line road. So SSD, side distance, minimum side distance is 2 into SSD. So remember it, okay? Remember it. For single lane road with two-way traffic, the minimum side distance is 2 into SSD. Okay. The reaction time is 2.5 seconds and coefficient of friction is given as 0.35 seconds. So it's a simple question. We just want to find the stopping side distance and we know the equation. Okay, it's the design speed is given in kilometer per hour. So we can write the equation SSD is equal to SSD is equal to 0.278 Vt plus V square by 254 F. 0.278 Vt plus V square by 254 F. So it will become 0.278 into velocity 60 and time given as reaction time is 2.5 seconds plus 60 square divided by 254 into F value is given as 0.35. So it's a simple equation. You can find the answer. The value will become 82.19. The value will become 82.19, but in the question it is two-way traffic. Two-way traffic on a single lane road. Two-way traffic on a single lane road. So side distance is equal to, minimum side distance is equal to 2 into SSD. It's equal to 164.38. 164.38. So the correct answer is option C, 164.42. Okay, next question. Okay, two cars are moving in opposite direction. Two cars are moving in opposite direction and with a speed of 25 meter per second and 20 meter per second. So the first car is moving at a speed of 25 meter per second and the second car is moving at a speed of 20 meter per second. Okay. If total reaction time is 2.5 seconds, so the reaction time is 2.5 seconds, design coefficient of friction is 0.35. The value of friction is, coefficient of friction is 0.35. Then what must be minimum side distance to avoid collision? Minimum side distance to avoid collision. So if both vehicles are coming in opposite direction, minimum side distance required is, if first vehicle applies brake, it should stop, right? It should stop and the distance where it stop is SSD1. And if the second vehicle applies brake, it should stop and the distance is SSD2. So minimum distance that should be available to avoid the collision is SSD1 plus SSD2. So we can find SSD1 and SSD2 and then add the values. It's that simple. So we can try. So SSD1 plus SSD2. Okay. SSD equation is, SSD is equal to Vt plus V square by 2GF because the speed is given in meter per second. So we can write SSD1 is, first vehicle is moving at a speed of 25 meter per second. 25 into reaction time is 2.5 plus 25 square divided by 2 into, given G value we can take it as 10, 2 into 10 into F is 0.35. So this is the equation for SSD1. Then SSD2 is again equation Vt, V velocity is 20 into 2.5 plus 20 square divided by 2 into 10 into 0.35. Okay, we can just calculate it. So we will get the answer as 258.93. 258.93 meter to avoid collision. So the correct answer is option D, 258.93 meter. Okay. So we can go to the next question. Okay. Calculate the safe stopping side distance for a descending gradient. Of 3%. Descending gradient of 3%. For a design speed of 80 km per hour, taking coefficient of friction as 0.35 and total reaction time as 2 seconds. So reaction time is given as 2 seconds. Normally we take it as 2.5 seconds and the coefficient of friction is 0.35. So we get write the answer, right? We know the equation. What is the equation? It's given, the speed is given in kilometer per hour. So we can write the equation of SSD as 0.278 Vt plus V square by 254 into F plus or minus 0.01 into n percentage. 0.01 into n percentage. This is the equation for ascending gradient and descending gradient. For descending gradient, we can put negative symbol, right? We can put the negative symbol. So this is the final equation. Okay, we can just substitute the values. 0.278 into velocity is given as 80, velocity is given as 80 and the time is given as 2 seconds. Okay, plus 80 square divided by 254 into F value is given as 0.35 minus 0.01 into, we should put n value in percentage, right? So 0.01 into 3 is equal to 0.03. 0.03. Okay, this is the equation. We can find the answer. It is equal to 123.22. The value is 123.22. So if you know the equation, it's very easy. For descending gradient it will be negative and for ascending gradient it will be positive. Okay. So the answer is option B, 123.26 meter. Okay. Next question. The minimum length of overtaking zone is, we know the minimum length of overtaking zone is 3 into OST. In some roads, we cannot provide overtaking on every places, right? We will put board like no overtaking. So in that case, we provide overtaking zones at regular intervals. The minimum length should be 3 into OSSD and the desirable value is 5 into OSD. So in this question, it is asked what the minimum length. So the minimum length is 3 into OSD. Okay, next question. Okay, what will be the shift of transition curve if the length of transition curve is 80 meter and radius of curve is 300 meter. We know what is a shift, right? When we are providing a transition curve, the road will be just moving inwards. So we should adjust the circular curve to a distance inside. This distance is called as the shift. So the equation for shift is S is equal to length of transition curve square divided by 24 into radius of curve. This is the equation for shift. What do you mean by shift? The circular curve should be put inwards because the transition curve was brought in place, right? As the transition curve was brought, the curve should be shift inwards. This is called as shift. Okay. So we can write in this question, the length of transition curve is given as 80 meter and the radius of gear curve is given as 300 meter. So we can write 80 square divided by 24 into 300. Okay, 80 square divided by 24 into 300. It is 0.89. 0.89. Okay, so the correct answer is option C, 0.89. Next question. If the speed of the vehicle is doubled, on a horizontal curve, then what will be the change in centrifugal force? So we know the equation for centrifugal force as WV square by GR. WV square by GR, where W, the weight of vehicle, is a constant here, G value is a constant, and the radius for this curve is a constant. So three values are constant, just the speed of vehicle is doubled. Okay, 2 times. So V square, that is V square. So 2V, the whole square, will become 4V square, right? So the centrifugal force, when V changes to 2V, centrifugal force changes to 4 times the centrifugal force. So the correct answer is option B, 4 times. Okay, next question. In equilibrium superelevation, the tire pressure of outer wheel in relation to the inner wheel will be. Okay. So when we are moving in a horizontal curve, the vehicle will have a tendency to overturn. So if you are providing a straight road without superelevation, then due to this overturning, the pressure will be more on the outer wheels. So what we will do? We will just provide superelevation. So a component of weight will act in this direction. And centrifugal force will act in this direction. And when we are providing equilibrium superelevation, these two values will be in equilibrium. Therefore, the pressure will be equal. In both the wheels. So when we are providing equilibrium superelevation, the pressure on both the wheels will be equal. And if we are not providing superelevation, the pressure will be more on outer wheels. So here the correct answer is option A, equal. Okay, next question. For the design of superelevation, for mixed traffic condition, the speed is reduced by. The speed is reduced by. So we know the equation. Superelevation is equal to, equilibrium superelevation is equal to V square by 127. Equilibrium superelevation. Equilibrium superelevation is equal to V square by 127. So for calculating superelevation for mixed traffic condition, we will reduce the velocity. To 0.75 V. Okay, we reduce the velocity to 0.75 V and we get the equation as this: 0.75 V square divided by 127 R is equal to V square by 225 R. Okay, so the velocity is reduced to 0.75. So velocity is reduced to 75%. Velocity is reduced to 75%. Okay, initially the velocity was 100% and it is reduced to 75%. But the question here is reduced by. So by how much value the velocity is reduced? It is reduced to 75%. So the value, it is reduced by 25%. 100% is reduced by 25% to get 75%. Okay. So the correct answer for this question is 25%. Okay. Don't confuse. If the question was reduced to, then the answer is 75%. But in this question it is asked reduced by, then it will be 25%. From 100%, 25% is reduced to get 75%. Okay, next question. As per IRC, maximum limit of superelevation in plain and rolling terrain and snow-bound areas is. In plain and rolling terrain and in places where there is snow, the maximum superelevation is 0.07. 0.07 or 7%. So its codal values, we can just look. For plain and rolling terrain, maximum superelevation is 7%. 7% or 0.07. For snow-bound areas, in places where there is snow, then here also the value is 7%. The maximum value is 7%. And for hilly areas means mountainous and steep areas not bound by snow, there is no snow, then the value can be 10%. So maximum value for superelevation is 10% for hilly areas with no snow, and for plain and rolling and places with snow it will be 7%. Okay, next question. A two-lane road with design speed of 60 km per hour. The design speed is 60 km per hour, has a horizontal curve of 400 meter. The radius of curve is 400 meter. What will be the superelevation required to be provided for the mixed traffic condition? So the question is mixed traffic condition or design superelevation at the curve as per IRC 38, 90, 98. Okay, we know the equation for design superelevation or superelevation for mixed traffic condition. V square by 225 R. Velocity is given as 60 km per hour. In this equation, we want to substitute as km per hour, right? Divided by 225 into radius is given as 400. Okay. is equal to 0.04. 0.04 or 4 percentage. 4%. So if you know the equation, it's very simple. Equilibrium superelevation, the equation for equilibrium superelevation is V square by 127R, and the question asked is mixed traffic condition. That means design superelevation. Design superelevation is V square by 225R. Equilibrium superelevation is V square by 127R. Okay, the correct answer is option C, 4%. Next question. Okay, the ruling design speed of a curve is 100 km per hour. The ruling speed is 100 km per hour and the superelevation is 7%. Superelevation is given as, design superelevation is given as 7%. Calculate the ruling design speed. Sorry, calculate the ruling design radius of the curve. Take coefficient of lateral friction as 0.15. So here the question is given, the speed is V is equal to 100, V is equal to 100 and superelevation is 7%, E is equal to 7% and then coefficient of friction is equal to 0.15. Coefficient of friction is equal to 0.15 and we want to find the minimum radius. We know the general equation, right? E plus F is equal to V square by 127R. This is the general equation for superelevation. Okay. If you know the equation, we can just place this R here. So, and we can put this here. So, we get R is equal to V square by 127 into E plus F. Okay. It is equal to V. The value of V is 100. 100 square divided by 127 into the value of E is given as 7%. 7% is 0.07. 0.07 plus 0.15. F is equal to 0.15. We don't want to study all the equation. We don't want to study this equation. We can just find this equation from here. So the answer will be 357.9. The value is 357.9. Okay. So the correct answer is option C, 358. Okay. Next question. Okay. Extra widening is provided on horizontal curves having radius less than. Okay. So if radius is greater than 300, if radius is greater than 300, we know extra widening is required. If radius is more than 300, no extra widening is required. And if radius is less than 300 and greater than 50, we can provide extra widening on both sides. We should give extra widening same on both sides. And if radius is less than 50, then superelevation is provided only on the inner side. Okay, so the question here is extra widening provided on horizontal curve having radius less than. We can provide extra widening only for radius less than 300 meter, and for greater than 300, no extra widening is required. So the correct answer is option A, 300. Okay, next question. What is the psychological widening on a pavement on a horizontal curve of radius 230 meter for rolling speed of 80 km per hour. So the question is psychological winding. Psychological winding. The equation is simple. Psychological winding is equal to V by 9.5 root R. The equation is V by 9.5 root R, V in kilometer per hour. So the value here is, V value is given as 80 divided by 9.5 root 230. Okay, we can just check. Zero point 555. 0.555. So the correct answer is option B. Okay. So the correct answer is option B, 0.555. Next question. Here the question is, what is the total extra winding? What is the total extra winding required for a payment of width 7 meter? Payment 7 meter on a horizontal curve of radius 100 meter if the longest wheelbase is 7 meter and design speed is 50 km per hour. So we know the equation. We know the equation, right? What is the equation? Extra winding is equal to psychological winding plus mechanical winding. Psychological winding is V by 9.5 root R and mechanical winding is NL square by 2R. NL square by 2R. So V value, V is given as 50 divided by 9.5 root. R is given as, the value of radius is given as 100. The value of radius is given as 100. Okay. And then N value. N is number of lanes. Here number of lanes is not given, but it's given width is 7 meter. Width is 7 meter means it is a 2-lane road. 2-lane road. So N is equal to 2. 2 into L will become, L is the wheelbase, right? L is the wheelbase. The distance between both wheels, it's equal to 7 meter. 7 square divided by a radius is given as 100. Okay, you can just check. It will be 1.01 meter. It will be 1.01 meter. So the correct answer is option C, 1 meter. Next question. The value of ruling gradient in plane as per IRC, in plane terrain. Value for ruling gradient in plane terrain as per IRC, the value is 1 in 30. The value is 1 in 30. We can just look. This value is also easy to learn. It's ruling gradient, limiting gradient, and exceptional gradient. Low ruling, limiting, and exceptional gradient. Here it's plain and rolling terrain, mountainous terrain, and steep terrain more than 300 meter. Steep terrain more than 300 meter, and this is steep terrain up to less than 3,000 meter. Here is plain and rolling terrain, it is mountainous terrain, and steep terrain more than 3,000 meter from mean sea level, and here it is steep terrain less than 3,000 meter from mean sea level. Okay, so the value is easy to learn. Just put 5, 6, 7. Okay, then here again put 5, 6, 7. Okay, then here it's 7, right? So 6, 7, 8. It's very easy to learn, and we just want to learn these two values, 3.3 and 6.7. Okay, it's easy to learn. So our question was, what is the ruling gradient? What is the ruling gradient for plain terrain, right? For the plain terrain, the value is 1 in 30. Okay, I already said, if you want to find, just write the 100 divided by 3.3, it will be 1 in 30. Okay, so the correct answer is option D, 1 in 30, and the values are easy to learn. Okay, next question. The ruling gradient is 1 in 20. So the gradient is 1 in 20. 1 in 20 means 5%. 100 divided by 20, it is equal to 5%. What is the compensated gradient for a radius of 120 meters? So compensated gradient, grade compensation is equal to, so question is compensated gradient. So the equation for grade compensation is equal to 30 plus R by R maximum 75 by R. 30 plus R by R, maximum value 75 by R. So the value is 30 plus, the value for R is 120. 120 divided by 120, maximum 75 by 120. Okay, so this will become 1.25, but the maximum value is 0.625. So the maximum value is 0.625. So this is greater, right? This is greater. So we can take grade compensation as 0.625. So compensated gradient is equal to gradient minus grade compensation. The question is compensated gradient. So the grade compensation value is G is equal to 5 minus 0.625 is equal to 4.375. 4.375%. So the correct answer is option C. What is grade compensation? When there is a curve, and a gradient, we should reduce the gradient in the curved area. This is called as grade compensation. And the value we reduce is grade compensation, and the new gradient is compensated grade. Okay. So the correct answer is option C, 4.37. Next question. Same question. For a hilly road with ruling gradient 6%, ruling gradient is given as 6%, with what will be the compensated gradient for a radius of 60 meters? So we can write grade compensation is equal to 30 plus R by R maximum 75 by R is equal to 30 plus 60 divided by 60 maximum 75 by 60. So 90 by 60 is 1.5 and the maximum 75 by 60 is 5 by 4, 1.25. Okay, so we can take just 1.25. So the value is compensated grade is equal to 6 minus 1.25 is equal to 4.75. Correct answer is option C. Okay. So the correct answer is option C, 4.75%. Next question. What is the type of curve? What is the type of curve used to connect +1 and -2 gradient? So the first gradient is +1, right? First gradient is +1 means ascending gradient. Second one is negative, right? Negative, so it is descending gradient. So for connecting an ascending gradient and a descending gradient, can we provide a valley curve? No, we cannot provide a valley curve. What we can provide? We can only provide a submit curve. For connecting an ascending gradient with a descending gradient, we can provide only submit curve. In another question, if the question is asked -5 and -2, so +2, then this will become -5 like this, and +2 is this. Here we cannot provide submit curve. We can only provide a valley curve. Another question we can write as two same values, -2 and -3, -2 and -6. So first one is -2, descending. Second one is -3. -3 is steeper, right? So first one is this, and we want to draw steeper. It will be like this. Here we can provide only submit curve. Okay, so in this question, the answer is submit curve. So for a plus gradient, for a positive gradient and a negative gradient, we can provide only submit curve. So if you draw two gradients, it will be very easy to find the answer. Okay. Next question. What is the deviation angle for +5% meeting on a -0.3%? So this is very simple. Deviation angle, the equation for deviation angle is first gradient minus second gradient. It's very simple. We don't want to draw anything. We can just write as first gradient minus second gradient. So first gradient is 0.5. (0.5) minus second gradient is -0.3. -0.3, it is equal to 0.5 plus 0.3, it is equal to 0.8%. It's very simple to do this question. Okay, so the answer is option B, 0.8%. Okay, next question. The design criteria for valley curve doesn't include which of the following? We know that this is a valley curve. This is a valley curve, and when the vehicle is coming, the weight will be acting downwards. Centrifugal force will be acting outside of the curve, right? So it also will be acting downwards. Both centrifugal force and weight are acting downwards. Okay. So when we come like this, a lot of weight is on the vehicle and there will be a comfort issue. When we will just come the valley curve, there will be a sudden issue for comfort. So first criteria is comfort criteria. Okay. Second one is, what if rain comes? All the water will go down, right? All the water will go down, and the second criteria is drainage. And the third criteria is, look, this is a valley curve, and when vehicle is coming, the light will be like this. The headlight will be like this. And if a vehicle is here, this vehicle cannot see it. So the third criteria is headlight sight distance. So if you provide like this, valley curve like this, then vehicle will collapse. So we want to provide like this. So minimum stopping sight distance is available, right? So we want to design for comfort criteria, drainage criteria, and headlight sight distance. But when we consider valley curve, no comfort criteria issue, because centrifugal weight is acting downwards and the centrifugal force is acting outside the curve, no issue. Then when water comes, water will go down, no drainage issue. Then no issue for headlight also. The only issue is the sight distance. Minimum sight distance should be available. When the vehicle is here, it should see the other vehicle. Okay, the minimum requirement is the only design criteria is side distance, the overtaking side distance, stopping side distance, and ISD. Okay, so for submit curve, only the side distance is considered, and for valley curve, there are 3 cases. Okay, so in this question, it is asked what is the design criteria doesn't include. Which of the following doesn't include? Headlight side distance is included. Overtaking side distance is not considered. Comfort condition is considered. Drainage is considered. So the correct answer is option B, overtaking side distance. Okay, so by this our questions are end. Thank you.